Hi, everyone. Thank you so much for being here, for attending my talk. There are multiple reasons why I'm excited to give this talk today. The number one is it's just very humbling to participate in this conference with such a diverse panel of speakers, such a talented panel too. I would like to ask everybody to give a round of applause to all the speakers and the organization for putting together something so great. Yeah. The second reason why I'm excited to give this talk is because I get to tell a story. It's not an overnight failure story. I've got many of those too. But this is actually a 9-month-long success story for my team. And the third reason why I love to share this talk is because it's a technology I'm very excited about. It's something I got involved a couple years ago, and I've been enjoying working with GraphQL. I've enjoyed working with Ruby on Rails for multiple years, and there are things that I'm excited to talk about. If you don't know me, my name is Netto. I currently live in big country. I flew in from San Francisco. I'm an engineering manager at Segment, but this is not a story about Segment. And also, I'm originally from Brazil, and I've been hearing so much Portuguese here. So Brazilians, please say hi. There's a bunch of Brazilians here. Not that many now. They're shy. OK, this is a story about when I worked at IFTTT. And for the ones that are not familiar, it stands for if this, then that. And I'll tell you the story about how me and my team helped build the next generation, the current generation of their project. If you're not familiar with what they do, it's exactly what it stands for, if this, then that. So you can connect different services online and make it work for you on an if this, then that fashion. So an example that I could use here is if I take a photo on Instagram with the hashtag EuRuKo, I want it to get tweeted automatically for me. So I can do all these sorts of things. I can back up all my photos to my Dropbox folder. I can automate searches on Craigslist or anything that you can think that you can use 2 different online services for. A little bit of context here. So it is an app that is loved by millions of users. There's a lot of people using it. And because it makes these connections between different services online, we're talking about billions of API calls every day just to make those checking connections, posting things like that. It has a website, an iOS app, and an Android app. A little bit about the tech stack at the time when we started this project. It was a seasoned Rails 3 monolith app. It had multiple versions for their APIs, API v1, v2, v3, internal API, developer API. And as it's normal with a lot of seasoned Rails apps, and I bet a lot of people would have an experience with that here too, is that over time, it gets really challenging to deploy, to iterate, to run tests. And I remember even booting our app would sometimes take like 40 seconds just for Rails server. And to make things even more interesting and fun, I was the only web developer working on it at the time. So we get this news. There's a challenge here. We're going to build an entirely new product. And that's very, very common if you're working at a startup. You're still trying to figure out product market fit. You're still trying to figure out how you're going to make money. You're trying to build the product that people love. And oftentimes, you're going to have to change a lot of things. And that's kind of what happened to us. But there was a caveat. There was a 9-month deadline for us to rebuild everything. So we knew we needed to make some changes. There was no way that that's going to be sustainable. It's an app that we can barely boot in development. And we're going to have to make these drastic changes. We're going to add a bunch of new features. We're going to deprecate a bunch of other features. We're going to change some other ones. We're going to build a radically different UI. There's no way that I can do that on my own. So there's this, and then there's this entire discussion about how you rescue a legacy Rails code base or any other code base. And the first thing that comes to mind is like, oh yeah, I'm just going to split it in microservices and everything is going to work fine. But There's an entire discussion about this, or just the Majestic monolith and the microservices. It's not my talk, but it's the first thing that comes to mind. And I don't think it's a binary decision. I think there's pros and cons to each one of them. And it's really a choice that you make, and you're going to have to deal with those consequences. But one thing to keep in mind here is we have a very small team. It's me working on back-end and web front-end, 2 Android engineers, 2 iOS engineers, and that's it. We need to build an entirely new product. Very limited resources, very tight deadline. So the more we thought about it, we realized that there might be a compromise that we can make, something that's kind of in between. We can create this hybrid approach that's a very rich API, and then we'll build some more specific clients. Instead of just going full on, all the way microservices, we might actually be able to take an incremental approach. And that's where we're going to get with this talk. But then the moment you make that decision, OK, we're going the distributed route. We're not going to keep everything contained in one place. We'll separate things a little bit. How do you make these different apps communicate now? So the first thing that comes to mind is through the database. And if you do that, that's the first answer that you're going to get from anybody you talk to. But let's dive into that a little bit. Let's talk about why database-driven integration are so tempting. One of the reasons it's tempting is that you get a really nice granularity when you're querying your data. Because you're co-located with your database, it's very easy to load everything that you need and exactly what you need with one round trip. And most importantly, especially when you're talking in the context of distributed systems, is that you have asset guarantees that your SQL database gives you. So now you don't have to worry about transactions, you don't have to worry about rollbacks, and all of those things, because they're all implemented in the database for you. But why are they challenging? Why it might not be a very good idea? And one of the reasons is that you end up having to repeat your abstractions everywhere. So if your database is your integration point, every system that connects to that database has to re-implement those abstractions that you have in your entire system. Rollbacks are going to be almost impossible because you're dealing with the structure of the data. And the same thing, if you make a deploy, you make a change to your database schema, and now you have 5 different services that talk directly to that database. How do you even coordinate all of those releases at once? So the other option, and the option that most people go with, it's APIs. But APIs are not easy either. They're also challenging. And there's a lot of challenges with the traditional APIs too. But one thing that I really love about the Ruby on Rails community especially is that it's very easy to create APIs. Rails makes that super easy for us, or Sinatra, or any other tool. It's very easy to just fire up a new endpoint and start writing code. So our community is used to this. And I bet a lot of people are going to relate with these challenges that I'm going to bring up. The first one of them is just the number of use cases. So there's this challenge now when you start to build an API, is that it has to cater to multiple use cases. You might have a use case that's an internal system. You might have another one that is a UI, and many other scenarios like those. There's one example that I read in this blog post once from SoundCloud, that they were going the microservices route, and they were redoing their UI, and just to render their track page with comments, they would have to make 38 AJAX calls just to talk to all the microservices that they have to. So there's this challenge now that you have to, do I make my APIs very rich and cater to every possible scenario at the expense of possibly making it more complex and slow, or do I make my endpoints with just one responsibility and leave it up to my clients to coordinate with all those endpoints? And then there's the different access patterns. You might have an iOS app that needs some data. You might have your website that needs just different data in a different format, in a different transport. And that just gets really complicated. Another problem is ambiguity when you're building an API. And the way to solve ambiguity is with documentation and conventions, or conventions. But conventions have a little challenge too. So this is the universal sign for OK. Everywhere I gave this talk, I would bring up this thing, and everyone's like, yeah, it's OK. That's what it means. Except where I was raised, this could mean something very offensive. If you're curious about it, you can come ask me later. Let's talk about GraphQL. It had just come out as an open source solution by Facebook. And there was a lot of hype around it. A lot of people were talking about it. So we decided to take a look to see if there was something that we could leverage. But this is what we're trying to solve. And one way to understand GraphQL is that it's a language specification to define and query APIs. And we're going to get more into that now. The first thing to keep in mind about GraphQL is that it comes with 3 main characteristics. The first one is that you can describe your data with types. And I'll show you an example of that. Here's a type. I'm creating a type that almost every Ruby developer is going to be familiar with. And I'm calling it a Ruby gem. And the type Ruby gem comes with 3 fields. A name field that happens to be a string, a downloads field that's an integer, that's the number of downloads, and a versions field that is an array of the version type. So I can make certain guarantees about the shape of my data here when I'm using GraphQL. There's a strong contract now that's enforced by a type when I'm using my API. The second characteristic is that you can load just what you need, only what your client needs to load. And here's an example. This is how a GraphQL query looks like. So I'm defining a query, and it's for the Ruby gem field with the name Rails. And I really want to know how many downloads the Ruby gem Rails had. So you can see that it's very product-centric. I'll let the clients dictate what they want out of my API. And the third characteristic is that you get predictable results out of it. When you combine type contracts with a query language that let you import only the data that you need, you get predictable results. So here's the result for the API call. I get my Ruby gem, its name is Rails, and it has that many downloads. There's a guarantee that the format of that data is not going to change. There's a guarantee that fields are not going to be taken away, and there's a guarantee that extra fields are not going to be included. GraphQL focuses on the clients. That's the takeaway from the entire talk, is that when you're writing GraphQL, you're thinking of the clients. GraphQL and Ruby are an awesome combo, and I'm going to show you why. I'm going to show you some code. OK, we can start here. So GraphQL, this is not necessarily GraphQL. This is just a GraphQL API. And what I did here to create a nice example was that I forked the rubygems.org codebase on GitHub. And I implemented a new API for them. And here's how it looks like. Let's start over. And this tool that we're using here is a tool called Graphical. It's just a user interface for exploring GraphQL UIs. So what's going on here is that, remember that I mentioned this thing called types? So now that I have types, I actually have documentation that's generated by my types. So what I'm going to do here is I'm going to explore this type Ruby gem that we just talked about, and I'll see, oh, it has a description. It's a package of Ruby code with specific functionality. And it has fields. It has a downloads field. It has a name field that's a string, and a versions field that's the type version. So I'm going to start writing a query here, and I'm going to start exploring my API. I'm going to type Ruby gems, and there's a Ruby gems field, and it says it returns a Ruby gem, and it actually loads a collection of all available Ruby gems. I'm interested in that. Let's see what's up. And I'm going to just open a bracket here, and I'm going to type name. And boom, I just ran a query now that gets the name of all the Ruby gems that I have in my local database here. And you can see it on the right. I'm just going to close this. That I get action cable, action mailer, blah, 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 a lot of Ruby gems. And let's keep exploring. Let's see what else can we do here. Downloads. the number of downloads for this Ruby gem. Let's see what's up. The same idea. I get 0 here because this is my local database, but in production you would get actual numbers. And I can keep going. There's a third field there called versions, and it's all versions ever published for this Ruby gem. Let's see what's this thing, and it gives me the authors, the dependencies, the number. Let's see all the version numbers. Oh, for Action Cable, I have 503. For Action Mailer, I actually have 2 versions for Action Mailer in my database, 403, 4271. That's really cool. Well, let's see code now. Let's see how do we do this. So here's an example that I put together. And remember that type definition that I just shared a minute ago? This is the exact same thing. And this is why I think Ruby and GraphQL are just such a great match, because the language is just so extensible and it's so easy to build DSLs that you actually get a really nice DSL like this. I haven't seen anything remotely like this trying other GraphQL implementations. So let's look at how this thing works. So I'm defining an object type. It makes sense. A Ruby gem is an object. And I'm giving it a name. The name for it is Ruby gem. That description we just saw a minute ago. And I'm just going to define a field called name, and it's of the type string. A field named downloads of the type int. And that's that exact same thing that we saw just there. The bang here right before a type string just means that it's a required field. It means that it's never null. My clients can be sure that a Ruby gem will always have a name. If I keep scrolling down here, this is how we actually implement that query. So I just listed all the Ruby gems in my database, and that's just plain old active record. I'll just do a rubygem.all call, and that will just return all my Ruby gems. And GraphQL will take care of transforming those Ruby gems into the Ruby gem type. And everything else here is just a little bit of boilerplate to make sure that we're doing the right thing. So basically, I'm doing the same thing, defining a few Ruby gems that returns an array of Ruby gem types. And I have to give the field a way for it to resolve itself, and it is to just download all the Ruby gems. So we go back here. Magic. All of those things are here now. Let's look at a little more advanced example. The same way that that's cool, but that doesn't, it's not any better than just doing REST with importing nested fields, right? Because I'm just hitting that endpoint with no parameters or anything. So here's another example. It's of defining another field that's a little more complex. I'm calling this field a Ruby gem by name. And basically what I'm doing is that it returns a Ruby gem type, and it takes in an argument. The argument's a name, and it's of the type string, and it's required. And same old active record magic down here. I get that argument by name, and I do a Ruby gem find by name. Let's go back to the demo. I'm just going to comment this out. Go all the way up. And I'm going to start typing. Same idea. I get my Ruby gem by name. It has that description that I just gave it. Ruby gem by name. And I'm actually just going to hit enter. Let's see what happens. Oops. Something's up here, and I got an error message. The field Ruby gem by name is missing the require argument name. That's really cool, because yeah, there's a type, there's a compilation happening for this field that I just defined, and I get a nice little error message here. Okay, let's keep going. Let's give it a name. Now let's look for mini test. Boom, right there, name mini test, and I could be building a page now that just shows some Ruby, a specific Ruby gem and the number of downloads that Ruby gem has. And I can keep going. I'm just going to get the versions again. And the versions, I'm going to get, who are the authors? Who's the author for Minitest? I don't know. Ryan Davis, for the 2 versions that we have. Let's see what version numbers are those. 5.10.3, 5.10.1. This is really cool. So another example here is just more types. I can go and I could enrich my Ruby gem types and just add more fields as I need. I could add created it at, I could add another field that's versions. It's that field that we're just looking at. And the way to load versions is just to do rubygem.versions. Really cool. I I might get the latest version. I might get the number of downloads. And I can define even more types. I can just keep defining my types. I can define the version type here now. And a version is a specific version of a Ruby gem. It has authors. It has a description, a number, a summary, blah, blah, blah. Same thing. More dependencies. A dependency type is a dependency for a specific version of a Ruby gem. Has requirements, has scope, has a name, so on and so forth. So it's really cool. So here's what happened. We built a GraphQL API on top of our monolith. So going back to the beginning of the talk, we're talking about why it's challenging and tempting to do a database-driven integration, and why it's challenging and tempting to do an API-based integration. And it turns out that we were able to find a solution that combines the things that are tempting for both of those. Because now I can get the granularity that I want for my data, and I can also deal with a lot of those challenges of also serving different clients with exactly the data that they need, and maintainability and documentation that just comes built in with the technology, because you're using types and because you're encouraged to define the description for those types that are collocated with the implementation. So basically what we did at the end was to use GraphQL as an integration layer for those services that we wanted to expose. So instead of breaking the entire monolith in different microservices, we actually just started to build new things outside of the monorail and connect them through GraphQL. And the exact same thing with our UIs. So here's how IFT's current architecture looks like. Except though we're writing software, we make mistakes, and that's kind of how it looks. So you can see clients there on the left, and then the internet, super reliable, an API gateway, you don't have to worry about that right now, and then services. And services go up and down, they get slow, they break. It's just the way things are. But you can see that different services now can actually go to the monorail in the GraphQL API and treat them as the source of truth. They don't have to talk to the database. We don't have to create a million different APIs in the monorail to cater to all of these different clients and different usages of the data. And we can actually have the UIs just talk to GraphQL when they have to. So that actually worked out really well for us. We still have all of those guarantees. The monorail still exists. It's still maintained. But they rarely have to touch it these days because a lot of the data models are already exposed in GraphQL. But of course, not everything's pretty. Not everything's perfect. There's also challenges with running GraphQL and Rails in production. And the first one is our good old friends, N+1 queries. And don't worry if you're not familiar with N+1 queries. We'll get there. But what I find funny about N+1 queries is that every single Rails code base that I worked on in my career, it always had challenges with those. They always had challenges with N+1 queries. And the reason is that it's too easy to just load data dynamically. It's too convenient. And sometimes we just overlook those things. And the reason why N+1 queries are just so obvious and they would come up so easily with GraphQL is that because we're actually requesting dynamic data. There's no way for our GraphQL server to know up front exactly what data that the client is going to need, because they could have just asked for anything, and we're basically just going to translate that to the database calls. And here's an example of a schema that we can look side by side. So I put together this simple schema for a restaurant, and it has a recipe type. And here on the left side is just the GraphQL type definition, pretty easy to follow. And then active record on the right, the one we're used to. And then a recipe has many ingredients, same thing in a GraphQL type, and the active record type. Same thing with the ingredient. The ingredient belongs to a vendor. A vendor has many ingredients. A restaurant belongs to an owner, and it has one rating. And same thing to the left. And we want to, let's say we want to write a report. I own this restaurant. I want to see where my ingredients are coming from and who are selling those ingredients to me. And I'll look at like the recipes, I'll grab their title. I'll check all the ingredients for each one of those recipes, all the vendors, and their name. I guess that kind of makes sense if I want to build that report. Here's how it looks like in our console or in production. Here's how you get to those 5 or 8 minutes API calls. So loading all the recipes, and then loading out the ingredients, loading all the vendors. And if we zoom in a little bit, here's how it looks like. You select the ingredients, and you join them by recipe ID, and then you select the vendors for each one of those. And if you have 1,000 recipes, all of them, they're being sourced by different vendors, this thing is just going to explode. This is a complicated problem to solve. It's really hard. It's super dynamic. I didn't have an answer for it right away, and I'd invested a significant amount of time building out a little bit more of GraphQL and this problem. And I thought about it for a long time, and I knew in my heart that we could not go live in production for millions of users expecting tens of thousands of requests per minute with inefficient database queries. There was no way we could do it. But remember the 9-month deadline and the other front end that I also had to build and these other APIs? So, YOLO. But not really. We actually found a solution eventually. Let's take a look. Let's take a second look at the data model. Here it is again. And one day I'm thinking about this thing and I'm trying to figure out how to do it. And it's funny that like we have our best ideas when like you just go to bed and it's like, oh, I just can't sleep because I just had an idea. I have to go back to my computer. And that's exactly what happened. And I started to think about these data models. And if you look closely, you notice that it's like they're actually super similar. They almost map one to one. So keep that in mind. And then I remember this nice little trick. The Active Record gives you this tool to include the dependencies for the data that you want to load. So if I were to build that report myself as a regular Rails MVC, this is what I would have done. I would have loaded all the recipes, included the ingredients, and preloaded the vendors with the ingredients. And let's take a look again at that GraphQL query. If you look at the left, here are my types. If I look at the right, those are my includes, the things that I'm trying to do. So that was when it clicked. I could actually translate the GraphQL query into the active record format because I actually have all of that information there. And I could write some code that translates those things and just hope for the best and hope that it works. And what's really cool about this here is because there is a language specification that GraphQL is a query language. There is an abstract syntax tree backing up every query that comes in. So the GraphQL Ruby gem has a feature that lets you tap into and introspect the query and get metadata information about it. So if the query comes in, I can actually get all that information, and I can translate it into the active record format for includes. And I'll warn you, the code does not look pretty. It's a lot of metaprogramming there. But I can get this. The moment that we feed that data that we got from the query into active record, we solve the n+1 queries because we're just hinting active record of all the types that it needs. And I put this together in this Ruby gem that I published called GraphQL Query Resolver. If you're curious, just go check it out. Go look at my horrible code there. And what did that mean for IFTTT? I still remember the day we flipped the switch. We killed all n+1 queries that we have in our old APIs, and we saw a 60% drop in database operations right off the bat. This was amazing. By just using all of this information that was available to us all this time, we could just save that. We saved a lot of money. Our services become a lot faster, and we managed to completely remove all the memcache dependencies that we had in our Rails app. It's beautiful. And because of this, it also unlocked a second feature when it comes to database optimization. And I like to call it selectively choosing your database environment. And what that means is that because, again, we have access to the GraphQL query coming in, and we know exactly which fields it touches, we know whether or not a query is read-only or if it has mutations or write operations in them. So you can write a little bit of code, and this is kind of how it looks like. And if you're familiar, if you build a more slightly with a Rails app that has slightly more traffic, you might have to have used a replica database or used active record, established connection, or any of those options to have more than one database in your app. We actually had that too. So you see the green, the bold green thing and the if statement is that if my query includes a mutation, I'm just going to run it in the main database that takes writes. And if it does not, I'll just use a replica database. And guess what? This is a consumer-facing product that has a ton of page views of people just browsing things. So it's actually close to like 90% reads and 10% writes. And what does that mean? It means that we completely eliminated contention locks from our database. And if you're not familiar with contention locks, this is a problem that happens when you have a lot of when your database has competing queries trying to write and read to the same rows in the database. And that's super common when you have things like updating a counter of how many people liked or added something on your site, and you're also trying to read those rows all the time. That's actually gone now because we're just routing the data. That because we have that information in the queries that are coming in, we can actually route the query or mutation to the correct database. Another big challenge, if you watched and paid attention to the talks today, to Anna's talk today, she talked about monitoring and error tracking and other things. And a lot of Rails apps are going to use a monitoring system or error collection app too. But they have one thing in common that's super common with web apps is that almost every tool for web apps are optimized on a per endpoint basis, on a per action and controller basis. And that's how you break down different endpoints and different functionality in your app. So with GraphQL, you remember the demo that there's only one API endpoint. So the moment you plug something in like New Relic, you get this. You get a pretty big lump of purple calls in there. Those are all that's the GraphQL endpoint. Oh, okay, it's beautiful. 90% of all the access is going to GraphQL, but I don't know exactly what they're trying to query. So not super useful. And the same thing happens to error. So our error tracking tool in New Relic had the same problem. Oh, I had 45 errors in GraphQL controller with no method error. But what could be going on here? I have 100 different types in my GraphQL schema. I don't know what's going on. And like undefined method empty for null class. I don't know what that is. Okay, we go back to, we have all of that information again. It's all available. It's all in the query. It's all in the language. You can tap into it. You can read the AST. Okay, let's get the query name. So if you looked at, you remember in the demo that I was doing Ruby gem by name? That's the query name. I can set it, oh, hey, New Relic, that's the name of the endpoint I'm trying to. You can't figure it out, but I'll give you a hint. That's what it is. And then you remember where we're defining lambdas to resolve each one of those fields? I wrote some code, more metaprogramming, that wraps all of those lambdas and just tells New Relic which lambda I'm trying to solve. I say, hey, New Relic, just report that under GraphQL field, the type name for this lambda, and the field name. I call the old resolver. Things are good. And boom, here it is. I got all my transactions again. I can see GraphQL, the channels query, recipe recommendation query, statements, action field, blah, blah, blah. They're all in there. My chart is back. No more big. It's still pretty big, the purple part, but it's actually one GraphQL query. That's the most common GraphQL query. And you see all the other top GraphQL queries showing up there. Same thing for errors. You'll get now different GraphQL endpoints and the errors and exactly where they happen. And I can actually know now where undefined method empty for null class is. It's in the recipe type for my GraphQL endpoint. That's really neat. If you're curious, if you want to see the implementation, it's really just a few lines of Ruby code. It's in this gist that I put together, GQL-RB-NR. And where to go next? If you're excited about GraphQL, if you think it's something that you could try out I would recommend checking out the GraphQL.org website. There's a lot of other features that I didn't mention here for the sake of time. There is the GraphQL Slack channel. There's the Ruby channel in that Slack group. I hang out there. Robert, the author for the GraphQL Ruby gem, hangs out there too. People are super friendly. A lot of GitHub people from the GitHub GraphQL API also hang out there. And yeah, check out the Ruby gem. If you do want to work with GraphQL, my team is hiring. Segment.com/jobs, or come talk to me. I have a lot of gifts. If somebody wants a t-shirt, or a fidget spinner, or a pair of socks, come talk to me after the talk. And feel free to tweet at me, to email me, and to grab me for questions. And thanks a lot. Thanks for being here.